Hello. So last time we talked about how we gather data and how we know if it's a credible source and whether we should believe it. Today we're going to talk about what we do with the data or how we understand the data. And that involves measures of center and spread, so how things come together and how they spread apart, and then also the shape that the data takes if you graph it in some way. So we'll be talking about those concepts today. So to begin with, what if I tell you that I had my iron level tested and my iron level is a 12.8? Well, does that mean anything to you at all? Are you like, oh, good job, Mrs. Freeze? Or are you thinking, oh, you should probably do something about that? Or are you thinking, are you gonna die? Um, Without having a context, a number like that doesn't really mean anything to us. We need to know how that fits into the whole picture of how it compares to other people's iron levels and what's normal and what's not. So just having one statistic without any context doesn't really tell you much. So what if I then say that an average iron level is 15? Does that give you a little bit better idea of how I stand if I'm a 12.8? Well, maybe. Means I'm a little below average on iron, maybe a little bit anemic there. But it doesn't really tell you how concerned to be yet. So besides just knowing how the center of the data looks, we also need to know how it spreads out. So if most people fall between um, 14.8 and 15.2, and I tell you I'm a 12.8, then you're like, oh, Mrs. Freeze. But if I say, oh, most people are between 7 and 23, well, then you're just like, huh, yeah, she's in there. So we need to know how the data spreads out. So those are some of the ideas that we will be looking at today. So in our notes here, which do you like how fancy I'm being right now? Oh no, my controls just went away. Oh, there it is. So anyway, the measures of center you have known for a very long time. Since you were a middle schooler, you talked about mean and median and mode in middle school. And struggling here. So mean is the average. So when you add them all up and divide it by how many you have. Median is the middle. It's when you put them all in order and you count in until you find the middle. The mode is the one that happens the most. You've known those for a very long time. We're not going to work on calculating those today. We're just going to use them. Okay. Measures of spread. Some of these are familiar and some of them are not. So range is from the highest to lowest. How spread out are they overall? That would be the range. Sometimes we give it as a like low to high, like from 1 to 55 or something like that. Sometimes we just subtract the two and say that we have a range of, say, 54 if you had from 1 to 55. So those are the two ways you can give the range. Interquartile range comes up if you divide your data into quarters, 25% sections, and you look at the middle chunk. So from like the 25th percentile to the 75th percentile. That is your interquartile range. So we want to see like how, if I look at the middle chunk, the middle 50% of the data, you know, what's their low to high range. So like if 50% of people's iron score or iron levels are between 12 and 18, well, then I would be in there. I would be in that like normal 50% range. So on the low end, but not like weirdly low. So that's one way you can look at how spread out the data is. Now, standard deviation, that's something new. We'll talk about that more in a little bit here. And then percentile ranks you are real used to, because whenever you get scores for like the ASVAB or your PSAT scores or something like that, it gives you a percentile rank. Like you scored better than 78% of the people your age, or you scored better than 95% of the people your age, or something like that. So that a percentile rank is a real common description of data. We won't talk about it much in this lesson, but you see it all the time in life and you know how to do with that. So, oops. Okay, there we go. Distributions, that's the shape of the data. When you graph it out, can have three basic shapes to them. normal. We can have a normal curve where it's kind of like even on both sides. We can have something that's skewed to the left or skewed to the right. So I'll show you what those are in a little bit here. So let me show you some features on Desmos that we will be using. Okay, so if you have a list of data and you want to put them into Desmos to do some calculations with them, you will want to give them a name. So I called this set W because it is about the weights of some basketball players. So I put W equals, and then you need the square brackets to tell Desmos that you are making a list. So the square brackets on my keyboard or over there by enter, you want the square ones to make a list. And then I just put all my numbers in. I have 14 players listed. That's why it says W is a 14 element list. So if I scroll over, you can see them all. 160 pounds, 165, 170, 170. I don't have to put them in order. I just got to put them in here, okay? Desmos can handle them being out of order. So I got all those kids in. There's 14 kids' weights listed in this spreadsheet. So let's say I want to do some calculations with this. So I'm going to go down to my second line on Desmos, and let's see. The features that we need will be in functions down here in our keyboard. So let's look, okay, so I already have my stats menu highlighted. It's blue here. So let's say we want to find the mean. There's a button that says mean, so I'll click that. Notice it opened up the parentheses for me, so I wanted to find the mean of my list W, and boom, there it is, 165.7 pounds is the mean or the average weight of these particular basketball players. So there's that. Maybe I want to find the, oh, how about the median? Here it is, it's in that stats menu, the median of W. Okay, it's 165. So if I put them in order, littlest to biggest, count in, find the middle, that's what it would be. So boom, there's that. The minimum and maximum buttons are on here. Now, really, it's not too hard to find a minimum value. You just look for the littlest one. But if you have a whole lot of data, let's say you have a survey of 2,000 people. Well, it might take a while to look through and find the minimum of those. So you can just hit this button, minimum of W, and that means the smallest person on our team weighs 150 pounds. Same idea with the maximum. Go down a line and go over to function. I want the maximum of W. Excuse me. It's 185. That's the heaviest person that we have listed. So let me get rid of some of these real quick. Now there's a nice feature here. Where is it? Okay, so it's in the stats menu. And then if you look in this third column over here on the right, we see a button that says stats. So if I click that one, it tells me a whole bunch of them all at once. It tells me what the minimum is, the median, the maximum, and then the quartiles, quarter 1 and quarter 3. So that will lead nicely into a box plot. That's something box and whisker plots you did in, I think, 7th grade is when you did those. So I'm going to come over here to function, and I want to see what this looks like. So they call that a distribution. So visualizations of these. So let me do a box plot, box and whisker of our set W. So do you see this little box and whisker plot down here? So the middle of the box is at 165, which makes sense because that's what the median is. The lower end of the box is at 160, which matches quartile 1, I mean. The upper end of the box is at quartile 3, so that's 170, and then the minimum value comes down here to the 150, and the maximum value comes up here to the 185. So that's a visual of the statistics you get from the stats feature on Desmos. We have some other ways that we can visualize these. So let me get rid of those. So let's go over here to functions, and let's see what a dot plot would look like for W. So, okay, so this, what it does is put a dot for each of the people's weights above their weight. So you can see the shape of the data this way. I'm going to show you that a histogram is basically, oops, I put that on the wrong line there, just a minute. There's my dot of W. Let's go down here and put a histogram of W on there. Okay, so it's the exact same picture. They just make bars instead of dots, so no big deal. I like the dot version, so I'm going to get rid of the histogram for a second here. Now I need to be able to draw on this, so let me open up these tools real quick. Well, I thought I clicked on it. Maybe I didn't. Oh, eesh. Don't know what happened there. Sorry. Okay, I think they're coming. Okay, so I said that we were going to talk about the shape of the data a little bit. And if I draw on here, see if I can do this. Yeah, okay. If I draw the overall shape of this, you see how it's a pretty even mound of data. Most of your data is up around where the middle is, how it's centered. So that's where your mean and median will kind of show up. And then it gets smaller as it goes out from there. And it's roughly even on both sides. It's not exactly even. It's okay. You can have one person that's a little heavier than somebody else. It's fine. But this is what we call a normal distribution. It's fairly even on the two sides. So that is what a normal distribution would look like. Let me go over here and add a kid. So somebody new is going to join our team. So I'm going to put somebody else over here. Maybe. Come on. Okay, we'll do this. Oh. Now maybe it'll let me. There we go. Okay, so we're going to have a couple of freshmen come, and there's one who weighs 100 pounds. Oh, wow. Okay, so do you see that dot down there? And so now if I draw my shape of my data, I've got to include that kid that's way over here. So we call this skewed to the left because, okay, so think of a skewer. Like if you're gonna make shish kebabs for the grill, you know, those pointy sticks that you put the food on? Well, this is pointy on the left-hand side. So we said say this data is skewed. It's like a skewer on the left-hand side. It's because we got to include that skinny kid who's way out there, who only weighs 100 pounds. Okay. And that 100 pounds, see how it's like way out there compared to the rest of your dots? That would be considered an outlier because it's like, whoa, this kid is tiny compared to everybody else. So that would be an outlier. Now, if there were a few other kids in here, let's clear that screen, go over here. Let's say there's also another freshman that weighs 110 pounds, and there's 115-pound kid, there's a 130-pound kid, there's a 142-pound kid. Okay, so this data would still be skewed to the left. See how it's like real pointy over there on the, that's a terrible drawing. On the left-hand side, because we have like a whole bunch of data, it's really low columns, but over there on the left, it goes way out there. So that's skewed to the left, like our other one was. But now I wouldn't really call that 100 an outlier because, yeah, that's the smallest kid on the team, but it's not like, whoa, he's tiny compared to everybody else, because you have some other small kids out there too. So you can have skewed with an outlier or skewed without an outlier. If it looks like it's getting narrower on the right, then we say that's skewed to the right. So that's what our different data sets can look like. Okay, so now we need to talk a little bit about standard deviation. So, let's go back to this screen for a minute. So let's say that the average iron level for somebody was 15, okay? So if 15 is the normal, the average, oops, that's not writing well. Let's see here. Sorry, technical difficulties. Let's go, I'll type 15 is the mean or the average. What if most people stay pretty close to that? What standard deviation is a way of saying how far up and down from that mean can we go and get most of the people. And this is something that you talk about a lot more if you go into a statistics class. The Algebra 2 level of this is just to kind of get the idea that standard deviation tells you how much up and down we can go to get most people. So let me draw a picture of this. So let's say 15. Oh my goodness. That says 15. 15 is the average, and we'll say that our data makes a norm. Okay. What am I going to do here? Just a minute. Okay, I'm back. Sorry about that. So we're back to talking about iron. I'm saying that the average person's iron level is 15. Let's say that the standard deviation on that is 2. So if I go 2 units up or 2 units down from that 15, where would I be? Well, if you take 15 and you add 2, you would be at 17. If you take 15 and you subtract 2, you'd be at 13. Okay, so if I look in that part of the graph, a lot of people will fall within 1 standard deviation of the mean. Okay, so you can think of it like this. Let me put 1 standard deviation. 1 standard deviation. If you stay within that, you'll capture a lot of the people. If you go 2 standard deviations, you will capture most people. And if you go 3 standard deviations, you'll capture darn near everyone. So you talk about these ideas a lot more in the statistics class, but by 1 standard deviation, a lot of the people, that would be about 68% of people will typically fall in that range. Okay, we'll talk about how you get that with our weight example in a little bit. 2 standard deviations would capture most people. I'm talking like 95% of people. So let's see what that would be in this case. Let me switch colors here. How about pink? So if I go up another 2 units, so I was at 17 on the upper end. So if I go up another 2, I would be at 19. Oh no. Oh no. Pink. There we go. 19. And if I go 2 more units below that 13, I would be at 11. So if I said, all right, I'm going to look at iron levels between 11 and 19, 95% of the population would fall in that range. That's what I mean by most. Most people will fall within 2 standard deviations of whatever measure. Now, 3 standard deviations, let's see what that would be. How about green for that? So my standard deviation in this example is 2. So if I go up another 2, I would be at 21. And if I go down another 2, I'd be at 9. So if I looked at iron levels from 9 to 21, by darn near everybody, I mean like 99.5% of people would fall in that range. So it would be something that's highly unusual to get something that's below 9 or above 21. That would be very, very unusual because almost all people will be within 3 standard deviations of something. So let's look at how this is calculated. Pause. Okay, so I'm back to my original set of weights for these basketball players. I took out those freshmen that I was adding in to understand the skewing effect. Remember, that's where it gets pointy on one end of the graph. It's not really even on both sides. Even on both sides is normal. So anyway, let's see. To calculate standard deviation, it's real complicated. We're not calculating it by hand. That's not in Algebra 2 standard. So luckily, there is a function that will do this for us. So go to your stats menu on Desmos, and where is it? There it is, STDEV. That button on the right stands for standard deviation. I want to find the standard deviation of W. So it looks like in this problem, it is 8.5 pounds roughly is my standard deviation on the weights. So, oh, I need to remember what the mean was. I forget what the mean was. So luckily that's an easy click. I'll go over here to functions and find the mean. So mean of W. Okay, so 165.7 is my mean here. So 8.5 pounds. Let's see, if I take 165, I'm just gonna round that to 166, 166 pounds. And if I add 8.5 pounds, I get 174.5. 174.5. If I take that mean, the 166 I'm saying, and subtract the standard deviation, the 8.5 pounds, I get 157.7, 157, or 157.5. So we talked about 1 standard deviation. That means most people will probably fall within 157.5 to 174.5 pounds. So let's see how many of our kids in our list actually fall there. So I'm going to go up to my list. So I'm looking for ones that are between 157.5 and 174.5. So 1, 2, 3, 4, not that kid, not that kid, 5, 6, 7, 8, not that kid, 9, 10, not that kid. Okay, so 10 of my 14 kids fell in that range. One question you'll be asked to do today is figure the percent of kids that fall within like 1 standard deviation of something. So I just got 10 out of 14 of my kids that fell in that range. And the way I found that range was I took my standard deviation and I added it to my mean and I subtracted it from my mean. So I would know like how high to go and how low to go to say I'm within 1 standard deviation. So 10 out of the 14 kids were in there. So that was 71% of my team. The 0.71 is the decimal form. I'm converting it to a percent because we typically talk in percents in the world. So about 71% of this team weighed in between 157.5 pounds and 174.5 pounds, which is what we would expect because a lot of the people will fall within 1 standard deviation. Most will fall within 2 standard deviations, and darn near everybody will fall within 3 standard deviations. And it's usually around 70%-ish, around 95%-ish, and around 99.5%. So that is what we would expect. So for your task today, you will be doing parts A, B, and C of question number 2 on page 1104 from your book. I'm going to put a PDF on this module as well so that you can just look there. You don't have to actually get in your book if you don't need to. Let's see what else. Oh yeah, you're also going to be gathering some data that we're going to use next time on Senses at School. So make sure to go to the next slide in the module so you understand what to do there. So I think that's everything. So remember that Jesus loves you and so do I. So do your math.